Hey folks, this video is about how to solve problems. Usually that means solving problems having to do with real life, which often doesn't come up in math, but when it does, it's pretty cool. Today it's very important. We're going to solve problems using circle geometry, and we are going to figure out the distance that Mary, who is standing right here, the distance that it takes her to walk from A to B, and then along this circular part, or arc, I guess, as we call it, this arc right here. So from A to B, and then to C. In order to understand this video better, definitely check out the video I started off called The Properties of Circles. Okay, it's very important you understand some basics before you go and do a question like this. And then there's also two more videos that have to do with finding the arc length and also finding the area of a sector, this being a sector right here. These are important things to know. So Mary, let's start. Mary is near a park. She's standing at this point right here. It's 20 meters from the center of the park that she is standing. Okay, she pays a fee and then she walks in a straight line to point B. Okay, and then she moves to point C right here along this arc. Okay. Now, using this diagram, we're supposed to find the length of Mary's walk in the park to the nearest tenth of a meter. So we're going to find this length. Now, the first length here is a straight line, and this is just a triangle here, okay? And one thing we know about this triangle, based on the properties of circles video that you watched, is that this is going to be 90 degrees right here. Why is that? Because this line right here is what we would call a tangent line, okay? And a radius from the center of the circle coming to meet that tangent line is always going to meet at 90 degrees. So that turns this triangle into a 90-degree triangle. And then to find this length right here, we can just use the Pythagorean Theorem, okay? You might recognize it as c squared equals a squared plus b squared, where c is the hypotenuse, okay? So 20 squared would be equal to, let's say, 8.5, let's call 8.5a plus b squared. This video assumes you've done the Pythagorean theorem before, okay? And you can use a calculator, of course. So we'll throw that over here, maybe over here. And let's quickly solve for b, okay? So we would go 20 squared, and we would subtract 8.5 squared, to give us 327.75, and then the last step would be getting rid of this squared sign, so we would take the square root of this answer here to tell us what b will be. What will be will be. Okay, Sarah, 18.1. There we go. 18.1. And what are the units? It's meters. Okay, so 18.1 meters is the distance from here to here, from A to B. Now, there's another part of this question, and I'll see if I can find an eraser just to erase this so we can see it better. We want to find this length from B to C now, and then we're going to add up our two answers. Okay, and that's where we need to remember from the previous video on arc length, the formula. Okay, here's the formula. Arc length is equal to the central angle over 360 degrees multiplied by 2 pi r. Okay, and hopefully you saw that video on how to find the arc length. So the central angle is something that is right here. It's when you have two radii and the angle that they make between them, okay? The angle between these two, okay? So 30 degrees is that angle, and yes, if you didn't notice that 30 degrees before, it's because I looked up and I noticed that I forgot to write that in the diagram. It's not even in the question here. So this question I wouldn't have been able to find right away without that 30 degrees being there. So yes, it did just appear, in case you're wondering. Where was that 30? Where did that come from? Okay, here it is. So You put the 30 degrees over top of 360. What that does, it gives us the percent of the circle that this arc length is going to cover. And then the 2 pi r is the circumference of the circle. So it's going to give us the percent of the circle. By the way, the radius is 8.5. And all of this is multiplied together to give us our final answer. I don't have a lot of room here. Maybe I will lift this up a little bit. And I'm just going to go on the calculator. Let's just move this over so you can see what I'm doing. 30 divided by 360 equals, then I'm going to multiply that by 2 times 3.14, and then multiply by 8.5. And I get 4.45. I'll just round it off. 4.45. And that would be meters. That is the distance from here to here, the arc length. Okay, so I'm going to add that up as well as this up. Okay, 14.45 plus 18.1. Of course, you could do it in your head if you wanted. Let's just say 22.5. Let's just round it off. So the total distance of her walk would be 22.5 meters. That is the total distance of her walk, and it would be good to write this as a sentence. Okay? It said to the nearest tenth of a meter. Thank goodness I did do that. 22.5 meters. So now we have one other question to do, and let's go look at it right now. I maybe should have done this video in 2 parts. I don't know, but I'm just going to keep going. Feel free to push pause if you need a break. Okay. Let's carry on. A kid's bicycle race is planned at Circle Lake. Here it is. Circle Lake is a circular lake that has a diameter of 4 kilometers. Okay, the diameter is 4 kilometers, as shown in the diagram below. So from here to here is 4 kilometers. Wow. Points A and D are the opposite sides of circular lake and lie on a straight line. Here's A and here's D. Okay, and they go through the center of the lake, with each point 5 kilometers from the center. So these are both 5 kilometers from the center. The course of the race is ABCD, where A and B and CD are tangents to the lake, and BC is an arc along the shore of the lake. So we're going from A, B, then we're curving along here to C, along that arc, and then to D again. So it looks like these 2 lines here are going to be the same length from what I'm seeing here, and A, B, C, D. Okay, so what do you want to find first? I guess normally it would make more sense to find the distance between A and B first of all, right? Okay, well, first thing you can do is draw a line from here to here. If the diameter of that lake is 4 kilometers, then that means the radius from here to here is going to be 2 kilometers, because the radius is 2. If the diameter is 4 all the way across, the radius has to be 2. We know this has to be 90 degrees because a tangent and a radius where they meet up on the edge of a circle is 90 degrees. So we've got 2 here, we have 5 here, and I guess we want to find this distance. That's just the Pythagorean theorem. C squared equals A squared plus B squared. And remember, the hypotenuse is going to be this side right here, because the 90 degree across from that is the hypotenuse. And one of the legs will be 2 squared and B squared. Now remember, it's like saying 25 minus 4, because we want to get rid of this 4 over here. 25 minus 4 is 21. And then take the square root of your answer. So the square root of 21 is 4.58. And that's the distance from A to B. I might just write that in. 4.58. Okay, and that's kilometers, but we'll figure that out later, okay? So I'm going to erase this because we won't have room to continue that. And just want to ask a question here. Is this distance really the same? Well, if this is 2 from here to here, and if this is 5 here, just like there, that means this also has to be 4.58. So we just saved some time. The very last thing we have to look at is the arc length here. And again, we have to remember our arc length formula. Okay? So the arc length, all you do is you take the central angle over 360 and multiply by 2 pi r. Now let's think about that for a second. What do we know here? We know what r is. R is 2. We don't know the arc length. We also don't know this angle in here. We don't know the central angle right now. Okay, so the problem here is that we don't know what the central angle is. We don't know what this angle is right here. Okay? Now, there's a few things. A straight line is 180 degrees, correct? So if we could find this angle right here and this angle here, which will be the exact same thing, if we could find these two angles and take 180 minus those two angles, we would have what's left on the inside, which is what we're looking for, our central angle. So let's see. Let's try and find this angle right here. You're going to need trigonometry to do this. This is a 90-degree triangle. And we're going to use, it's up to us, let's just use the 2 and the 5. So the 2 would be our adjacent side, and 5 is the hypotenuse. So adjacent and hypotenuse is cosine. So cosine of theta there would be adjacent over the hypotenuse. And remember, to find the angle, you always need your second function button, or the inverse button, whatever your calculator likes to call it. So 2 divided by 5 gives me this decimal. And then I want the inverse of cosine is 66.4. So I'm just going to round it off to 66 degrees. Okay? So I get 66 degrees right here. I know this is going to be the exact same thing because it's the same triangle. So then I just go 180 minus 66 minus 66 again will give us 48. We have just found our central angle. The central angle is 48. Okay? The central angle is 48. And I'm going to multiply by 2 times pi times, and the radius happens to be, the radius is also 2. I know that looks weird. Let's multiply this out on our calculator so we can figure this out and be done with this question and this video, which is taking so long. 48 divided by 360. And we're going to multiply by 2 times 3.14 times 2 again. We get 1.67. 1.67, and that's kilometers. Now all we have to do for our final answer is take 4.58, because that's the distance from A to B. Okay, then B to C is 1.67 kilometers. And then 4.58 kilometers again. I don't know why I wrote kilometers there, just because that is not very consistent. Our final answer should have kilometers in it, and let us do that right now. So 4.58. I'm just going to multiply by 2. It's the same thing as adding them both together. Plus 1.67. 1.67 is 10.83. 10.8. It says to the nearest tenth of a kilometer. Kilometers. That is how long this kids' bicycle race is. Have a great day, folks.